Hello everyone, this is Concept 62, Graphing Rational Functions. When I first recorded this video, it actually took more than an hour to do, so what I instead decided to do is go back and re-record but show you guys everything already on here. That way it can, we can just condense it, so that we can complete this lesson within one period. But yeah, here goes. So a rational function is a function of the form f of x is equal to p of x over q of x, where p of x and q of x are polynomials and q of x is not 0, right? Because you cannot divide by 0. So these have a slightly different form. If you guys recalled when you were looking at your study guide, some of you asked me like, wait a minute, this one right here this particular problem looks different. It's not like the standard form of a reciprocal function, and that's true because it's actually something else, a rational function. So the steps to graph are listed here. Okay, now pay very close attention to how it works. The first step is what we've been doing for the last number of concepts, simplifying. Okay, so you're going to simplify the function first. The second step, you're going to find the x-intercepts by setting the numerator equal to 0. Step 3, you're going to find the vertical asymptotes by setting the denominator equal to 0, right? This will tell me what values x can't be, because then q of x would be 0. Okay, so that's your vertical asymptote. Finally, two more. Find the horizontal asymptote by using the rules below, and here are the 3 cases we have for horizontal asymptotes. Okay, if the degree of p is greater than the degree of q, and recall that when we say degree now we mean exponent. Okay, so when the exponent of the top polynomial is greater than the exponent of the bottom of q, so let's write top to bottom, maybe that's better. Okay, there will be no horizontal asymptote. Okay, when the degree of p of the top is less than the degree of q, the bottom, your horizontal asymptote would be the x-axis, or y is equal to 0, right? That horizontal line is the x-axis. Okay, and then when the degree of p is equal to the degree of q, then the horizontal asymptote will be the leading coefficient of p of x over the leading coefficient of q of x. So it could be a fraction, for example. Okay, and then finally, the last thing, you're going to identify any holes in the function. Okay, so what is a hole? A hole is a point x comma y at which there is a break in the graph. A hole occurs when there is a common factor between the numerator and the denominator. So whenever you simplify, step 1, if you do, then you know you're going to have a hole. To find the x-coordinate, set the common factor equal to 0. To find the y-coordinate, substitute that x-coordinate into the simplified function. So this concept of a hole is not necessarily new. We've seen them in the past already, especially with piecewise functions. If you guys remember, when we first learned how to list domain and range for piecewise functions, there were some values in which the domain did not exist for. That's basically what a hole is where the graph is discontinuous. So for this first one, okay, so this is where it gets very tedious. This is what I mean why it took so long to record my first attempt at this. Okay, so here's the function that's given. Okay, I have x minus 4 over x plus 4. Step 1 would be to simplify, and I cannot simplify. So my next thing would be to find any x-intercepts. You set the numerator equal to 0, so I had x minus 4 is equal to 0, and I got x is equal to 4. So my x-intercept here would be 4 comma 0. Okay, now to find my vertical asymptote, I would set the denominator equal to 0. So x plus 4 is equal to 0, and I got that x is equal to negative 4. So therefore my vertical asymptote is that x is equal to negative 4, and it would be right here, this dashed line that you could see. Okay, now my horizontal asymptote, okay, so I have to look here. Right, so x minus 4, x plus 4, and here are the rules. Let's go back up to this a little bit right here. Okay, the degree of the top, the exponent, is the same as the one on the bottom. So this is actually this case here. So it's going to be the leading coefficient of P of x over the leading coefficient of Q of x. What's the leading coefficient here? Well, it's going to be 1 and 1. So it's just 1. So my horizontal asymptote would be at y is equal to 1. Okay. There's no holes because I did not simplify. Okay. So then, oh, that's right. So here's my horizontal asymptote. Now, how do I know what the graph looks like? Okay. You can create a table, or if you're at this point, I would hope that we're really good at just evaluating x points. Okay, so I know for a fact I have the x-intercept at 4, 0. So there's going to be a point there, this one here. Okay, now let's plug in something that would be, you know, in this quadrant here. Well, not this quadrant, but this side of the formed by the asymptotes here. Okay, so look at my x values. Well, the easy one to plug in would be 0, because this lies right along the y-axis and it's in this side of the asymptotes. So when I plug in 0, I get 0 minus 4 over 0 plus 4, negative 4 over positive 4, and I get negative 1. So I have a point here. Okay. Now, I believe here I took also negative 2, so when I plugged in negative 2, I got negative 6 over positive 2, which gave me negative 3. So here's where my other point is. And then I took one more. Okay, negative 3. So when I plugged in negative 3 here, I got negative 7 over positive 1, and I got negative 7, this point here. So then I know in this part of the this part of the plane formed by the asymptotes here, I'm gonna have this graph here. Okay, this curve, sorry. So now I need to figure out, okay, well, what's the rest of it? Okay, so then let's keep going. I have my asymptote next, and then let's go here. X is equal to negative 5. So when I plug in negative 5 here, I'm going to get negative 9 over negative 1, or positive 9. So that would be this point up here. Okay, and then I plugged in negative 6, I get negative 10 over negative 2, which gives me positive 5. That would be this point here. Okay, don't lose track or don't get confused because of the asymptote, right? The asymptote are not my axes, right? I want to count 5 up from here. Okay, so just to not cause any confusion. So lastly, and then of course be strategic about which points you want to put in, because you might end up getting a fraction and you don't want to deal with it. I mean, you might end up, but just think about what gives me whole numbers. Okay, so in the next one here, I plug in negative 7. I'm going to get was it negative 7? Sorry, hang on. Negative 5, negative 6, and 7, negative 8, sorry. So negative 12 over negative 4, and I'm going to get positive 3. That would be this point here. And I could stop right there, and I already know this graph is going to look like this. Okay, so it's just conditional how many points you want to evaluate for so you can get a graph. Now, you guys know how I am. I do want you to have accurate graphs. And a reminder that you are not allowed to use a calculator for this upcoming unit test. So yes, you need to know how to find them. Okay. Again, if you need to use a table, that's fine. Basically, what we just did here was basically describing a table, but just do as much as you need. But there's just be mindful of the lack of space. All right. Next one, I have f of x is equal to 2 of x, f of x is equal to 2x minus 6 over x minus 1. Blah. Okay, messing up. Alright, so then first step would be to simplify, right? Now, yeah, I could pop out a 2 here on the numerator, and I'm going to get 2 times x minus 3. But then that doesn't cancel with anything in the denominator, so it really, there's nothing I can do to simplify this. So there's no whole as well. That tells me that immediately. So let's find our x-intercepts. We'll send the numerator equal to 0. When I do that, I find that x is equal to positive 3. Okay, so I'm going to have a point at 3. Okay, for my vertical asymptote, I'll set the denominator equal to 0. So x minus 1 is equal to 0. So I get x is equal to 1. So I'm going to have this dashed line going like this, right? Okay, for my horizontal asymptote, right, let's look at our cases here. We're looking at the exponents, right? Now notice that the exponents would be technically the same. It's degree 1 on top, degree 1 on the bottom as well. So it's the third case, right? The degrees are exactly the same, so it's the leading coefficients. and in this case it would be 2 over 1 or 2. Okay, so then my horizontal asymptote will be here. Y is equal to 2, x is equal to 1. Okay, when I forgot to describe, since my x-intercept is 3, I have 3 comma 0 here. Okay, since I didn't simplify, there's no hole. Okay, and then so from here now I start to describe the graph, right? So I'm going to start plugging in. So in this side of the asymptotes, let's take some x values, right? So I believe I take 2. So when I plug in 2, I'm getting 4 minus 6, I get negative 2 over negative 1, so I'm getting negative 2. So I end up here. Okay, there's my x-intercept, and then right here I'm going to have 1, 2, 3, 4, 5. So when I plug in 5, I get 10 minus 6, I get 4. Okay, yeah, 4 over 5 minus 1, 4. Okay, and then I get 1. So I'm going to get this point here. Okay, so you can stop right there, and you already have the 3 points, and then this is going to be a curve going like this. Okay, similarly, you can take some points now here. So thankfully I do have the y-axis, it's available, so I can plug in 0. So when I plug in 0, I'm going to get negative 6 over negative 1, which is just positive 6. So that's going to be this point here. Okay, and then I can plug in negative 1 as well. So negative 1 here, I'm going to get negative 2 minus 6. I'm going to get negative 8 over negative 2, and I'm going to get positive 4. So that's going to be this point here. Let's take one more. I have, let me see, negative 1, negative 2, negative 3 here. Okay, so if I plug in negative 3, I'm going to get negative 6 minus 6, so negative 12. Negative 3 here over negative 4, so negative 12 over negative 4, I'm going to get positive 3. So that's going to be this point right here. Then I can stop right there, and then I would just know that it looks like this. Okay, I think I forgot to describe the domain and range in the previous one. Maybe just go back or just look at the graph after I describe this one, right? It's pretty much all x's, it's right, except wherever your asymptotes are. Those are where you can evaluate with x. So all x's such that x can be 1, and then same thing for the range. You can have wherever the horizontal asymptote is, that y value won't exist. So y such that y can't be 2. Okay. I know the notation keeps changing. I think we're going to have to transition more towards this, because as we head into pre-calculus and AP calculus, this is going to be the common notation that you'll see as far as domain and range goes. So, I mean, I won't be, petty or any of that going into the end of this class, the end of the year, but try to get used to this notation going forward. All right, number 3. So here's our first case where we do have canceling. Okay. X squared minus 1 is a difference of squares. It factors out like this. Okay. Now, so I do have a common factor on top and the bottom. So I am going to have a hole. Okay. So these would cancel and I get x plus 1. So this function here is really just x plus 1. So my x-intercept, okay, well, I get left with this. Technically, it could be a numerator if you just put it over 1, right? So I could find an x-intercept, x plus 1 equals to 0, and I get x is equal to 1. So I'm going to have, did I mess this up? I think I messed my graph up. Yeah, I messed my graph up. It was supposed to be at 1 comma 0. Oh, jeez. Okay, so then, anyway, so just be mindful that this graph is incorrect, okay? I don't have any vertical asymptotes, no horizontal asymptotes, because there's nothing really to have there. But notice that it's just a linear function, right? My whole, because I canceled these two, so this is the common factor that I'm gonna have to set. This is the common factor that I'm gonna have to set equal to 0, so I can find what my whole is. Okay, so I have to find the x coordinate first. It would be x minus 1 is equal to 0, so I get positive 1. When I plug that back in, I plug it in here, okay, I'm going to get 2. So then my whole is at 1 comma 2, and that would have been where you see the open circle. Okay, so knowing this is it's just a linear function, right? Slope is 1 over 1. It intersects positive 1. I am going to have Oh, no, I see what threw me off. Sorry guys, this should be -1 here, right? It should be -1 when I subtract 1. Duh, threw me completely off. Okay, so it doesn't, so my x-intercept is -1. Let's just review. Okay, so -1 comma 0, there are no asymptotes, and then my hole was at 1 comma 2, set equal the common factor equal to 0 here, and you'll find that x is +1. Factor back into the substitute back into the simplified function, and you get 2, so 1 comma 2. So then what's my domain? Well, all x's are possible except where there's a hole, and that was at 1, right here, so x can't be 1. My range, well, all y values are possible, right, except where the hole is, which is when you plug in 1, you get 2. Okay, so that's this function here. Number 4, I have x plus 5 over x squared plus 9x plus 20. So what I do is I factor out the denominator, okay, and then I simplify. So immediately I have common factors here, so I am going to have a hole. Okay, when I simplify this, I get 1 over x plus 4. So this one is familiar. It should be like a reciprocal function, right? So this one we shouldn't have too much trouble graphing. You already know that your x-intercept, sorry, your vertical asymptote is going to be at -4. So you're going to have this line here. Okay, horizontal asymptote, there's no shift, right? So it's going to be right along the x-axis. Y is equal to 0. And then your hole, so because you factor these two out, right, you're going to set this factor equal to 0, you're going to get -5. Okay, now remember, you plug it into the simplified function, okay, because it's the same thing. This is really just this. So when you plug in -5 here, I'm going to get 1 over -1, which is -1. Okay, so make sure you go put your open circle. Okay, so that's this one right here. That's -1 comma -5. Okay, so to be able to graph this, right, pause the video if you want, and then just take a few points as we've been doing in the previous graphs, so that you can just get the rough sketch of what it looks like. Make sure, however, the graph is passing through this or connecting into this open circle, right? So then what's my domain? Domain will be x such that x can't be where the hole is, -5, and of course it also can't be my vertical asymptote, -4. My range is y such that y can't be -1, which would be my, this would be the hole, and 0, which would be the horizontal asymptote. Okay. Number 5, they keep getting more crazier, more interesting. Okay, I have the numerator and denominator, so I'm going to have to factor these guys out. When I factor out the numerator, I'm going to get this right here. Okay, when I factor out the denominator, I'm going to get this right here. Okay, notice that if this one is different than the previous ones. Okay, now more on that in a bit, but notice that you cannot cancel or simplify anything from the numerator to denominator, right? These are just completely different factors, so there's going to be no hole. Okay, now for your x-intercept, you're going to set, remember, your numerator equal to 0. Now you have two factors here, 2x plus 1 and x minus 1. Okay, that's perfectly fine. What this means is you're going to have two x-intercepts. Okay, so the first one, you have 2x plus 1. This marker is already done. 2x plus 1 is equal to 0. You're going to have x minus 1 equal to 0. Oops, and this is for my x. This is for my x-intercept. Okay, so you're going to find that x is equal to 1/2 or 0.5, right? Or negative 1.5, I should say. No. Negative 1/2, and this would be x is equal to 1. So I have two x-intercepts, and these are right here. Negative 0.5, which is just a half, negative half, and then 1 comma 0. Okay, for my vertical asymptotes, I'm going to set the denominator equal to 0. Same thing, I have two factors. Okay, so I'm going to have a vertical asymptote at x is equal to 4 and at x is equal to -3. Those are this here, and therefore I'm going to have two lines going like this. Okay, these are my dashed lines. Sorry, these are my asymptotes. Okay, I do have a horizontal asymptote as well. Now look, I get the degree. I have exponent 2, exponent 2, so they're actually the same. So once again, we have case 3. So I'm going to go by the leading coefficients. The leading coefficients is 2 and 1, so it's 2 over 1, which is just 2. So I have a horizontal asymptote at y is equal to 2, which would be here. Okay. There's no hole, right? We said, because nothing simplified. So then we could already pretty much already listed the domain and range, right? The domain is all x's such that x can be wherever the vertical asymptotes are, and then y can't be where. So right here, right? Y can't be 2 going up. Now I have less than 0.09, right? Which is really close. What's just really small decimal, and I'll explain why. Okay, in a bit. What you need to do is take some points, right, in so along the x-axis, along the left of the first asymptote. Okay, you're gonna get this graph here. So pause the video if you can, take 2 or 3 points. Okay, 3 points I recommend, and then you're gonna take x points here. Let me see if I can get. Sorry, because I watched the stream at the same time as I'm recording here. You're gonna take x values here, and you're gonna get this graph here, parabola-like. Okay, so this one I would say plug in maybe 4 values so you can actually see it. Okay, and then you also have your x-intercepts already helping you out. These 2 points here, I don't know if you guys can see them. Okay, those are my x-intercepts. So maybe just take one here and one here, and you'll see that it's parabola-like. Okay, and then finally, you're gonna take some x points on the right side of the other asymptote here. Okay, and you're gonna find that you get this graph here. Okay, so for my range, notice that it's pretty much all y values greater than y is equal to 2 above my asymptote here. But when I go towards the bottom, okay, okay, it's not everything up to 2 either though. Okay, it's not. As a matter of fact, it's only up to as high as this graph gets. So how do you know what's the highest point? Well, you have 2 x-intercepts, and you know that the turning point would be somewhere in between there. So what you can do is, excuse me, you could take the average of the x's, right? You're gonna get some middle value. What's in between -0.5 and 1? You're gonna get 0.25. Okay, so you're gonna evaluate this at 0.25, and you're gonna get that roughly it's 0.09. That's as high as this graph goes. Okay, you can round to the nearest 10th, to the nearest 100th, but I do need to see that you understand that the range is not everything up to y is equal to 2. There's no part of a graph here. Okay, all right, we're getting there, guys. Number 6 here, factor out an x squared. I get it. This here in the numerator. The denominator factors out to this here. Okay, now I do have common factors, this one and this one, so these would simplify. So all this is really just this function here. Okay, now that means I do have a hole, right, because I canceled out, right? My x-intercept, let's set the numerator equal to 0. Okay, x squared is equal to 0. I'm just get 0. So I have an x-intercept at 0, 0, and then when I plug in 0, I get 0 over -1, which is just 0. So I have a point here. Okay, my vertical asymptote would be setting the denominator equal to 0. So I have x minus 1 is equal to 0. So I have 1 at 1. Okay, that's this guy here. So here's this horizontal line. My horizontal asymptote, right? So I'm gonna have this case here, the first one. Degree of p is greater than the degree of the q. The top exponent is greater than the exponent of the bottom, right? Squared, non-squared, it's just 1. So there is no horizontal asymptote, so I only have this vertical one. Now, for my hole, right, I'm going to have to set the common factor equal to 0. So that was x plus 3. So I get x is equal to negative 3. Now when I sub negative 3 back in here into the simplified function, I'm going to get positive 9 over negative 4. Okay, which is just negative 9 over 4. So then I'm going to have a hole at this value here. And then I have it approximately right here. Okay, it's hard to see, but it is an open circle. Now, I can already list my domain. It's all x's such that x can't be where the hole is and where the vertical asymptote is. Those are negative 3 and comma 1. For my range, okay, let's pause on the range again. So this one, you're probably seeing like, whoa, like what is this, right? It looks really, really different. Okay, same thing I want you guys to do. Take some x values to the left of the asymptote and take some x values to the right of your asymptote. Okay, and as you take, I would say maybe 4 to 5 points to the right and to the left, you're gonna start getting your shape. Okay, so I think I only took a few points here, right? So I mean, you'll see that it's not gonna always be hyperbola-like. Okay, so I need you guys to go ahead and do that. Okay, practice the skill of evaluating your x points here and then see what you get. Okay, now for my range, okay, well, assuming you already have your graph, okay, for my range, notice that for this bottom semi-parabola looking thing, okay, I have all y's such that y is less than 0. That would be this graph here, right? Because it stops here, right? It goes from here to the bottom. It says, or y is greater than 4. That's going to be going up this way, right? Because everything in between here, there is no graph. So my range does not exist in these points here. Okay? And then finally, y cannot be negative 9 over 4 because that's where my hole is. Okay? So that's this graph. Okay, next one, I have x minus 6 over x squared minus 6x. I can factor out an x in the bottom, and I get this. So I do have a common factor, these. So I am going to have a hole. Okay, so all this is really just 1 over x. Okay, now for my x-intercept, notice that I have a just a constant in the top, 1 over x, right? So there is no x-intercept. Okay, and notice too that this is just a reciprocal function, right? With just a parent reciprocal function with no horizontal or vertical shift. Sorry, I lost my train of thought there. So it's just 1 over x. So this one it's one we should know, right? You have your asymptotes right along the axes here, and then you do have a hole though. That's the only difference, right, compared to the parent function, because we did have to cancel these guys out. So I get a x is equal to 6, and then when I plug into the simplified function, I get 1 over 6. So then your hole is going to be roughly, right, you're going to go all the way to 6, 1, 6. So it's just, you know, as close as possible you get it to the x-axis there. And then you can list your domain and range as well. Now, you have all x's such that x is not the vertical asymptote, and it can't be 6, which is where your hole is. For your range, y is everything except y can't be 0, which is your horizontal asymptote, and then of course where the hole is as well. Okay, so that's this one. Number 8, I have these two polynomials here. So when you factor them out, I got this on top and this on the bottom. Okay, and then these two guys here are going to cancel out. So I get left with just x minus 4 over x plus 5. Now, I do have a hole because I simplified, right? So my x-intercept here, set the numerator equal to 0, I get 4. So 4 comma 0, and I'm going to have this point here. Okay. For my vertical asymptote, I have x is equal to negative 5. So for vertical asymptote, set the denominator equal to 0, I get negative 5. So that's going to be this line here. Okay. For my horizontal asymptote, those are the three cases, right? Notice that the degree for the top is the same as the degree of the bottom, right? So this is the third case. So it's just leading coefficient over leading coefficient. So it's just 1 over 1, and I get y is equal to 1. So I have this horizontal asymptote, here. My whole is set that common factor equal to 0. I get x is equal to -7. When I plug -7 back in here, I'm going to get -11 over -2. So that simplifies to positive 5.5. So then my whole would be here. Okay, so this is -7 comma 5.5. And then to find the how it looks, same thing, right? Take some x values to the right of your asymptote here, and take some to the left as well, and then you're gonna get your points, and then you'll be able to sketch what it looks like. Okay. Next one, number 9. I have this polynomial here over this one. Okay, I can factor out the top and the bottom, and I get this here. When I cancel these two guys out, which means immediately I'm going to have a whole, okay, I'm going to get x minus 5 is equal to 0. To find my x-intercept, set this equal to 0, so I get 5 comma 0. So that's this line here. Okay, my vertical asymptote, can you guys hear the vacuum? I apologize if you guys can hear it. My vertical asymptote, okay, set the denominator equal to 0, but it's just a constant, so I'm not going to have one. Okay, now for my horizontal asymptote, right, so let's see what my cases are. I have a constant, I have a constant in the bottom, and I have a x minus 5, right? I have a non-constant on the top here. Okay, so technically you have, you know, it's going to be case 1, because the degree of the top right here, you know, you have a linear function over just a constant. The degree here would be greater. This one, the degree would be like 0, right? So 1 over 0. So you have the first case, no horizontal asymptote. Okay, so then for my whole, you're going to set x plus 1 is equal to 0. So I get -1. Plug this back in here, I get -6 over 2, you get -3. So my whole is at -1 comma -3 here. My domain therefore is all x's. You can clearly see, right, it's all x's. This is just notice that it's just a linear function. Actually, maybe it'd be easier to see it if I write it like this. And I apologize because my marker is dying. It's really just this right here, right? That's a linear function. Slope is 1/2. My y-intercept is -5 over 2, somewhere here. Okay, so then my domain is where the whole is, all x's except where the whole is, and then my range is all y values except where my whole is. Okay, and that's it. I hope it's not too bad. I would say the hardest part of this concept here was probably just figuring out what some of the more interesting looking graphs look like, such as like number 5, and I believe it was number 6. Okay, but this is it's just a skill being able to evaluate those x points to the left and to the right of the asymptotes, and then just getting a general idea by your points that you're getting on what it looks like. Okay, anyway, till next time.